So these are notes on this 3D Mach 3 breakout board that I'm swapping this parallel out for. In my last video I talked about how I thought that these limit switches were over here on the left, but turns out they're over here on the right, I think. I'm not even sure, but disregard any of that info. Anyway, let's see if we can get a little glare off of here. That might be better. Alright, so the stepper motors are connected here, X, Y, Z, A. And here is the 5 volts or ground for that signal. They go over into this area of the driver. These are closed loop drivers for this type of stepper that has an input pulse and also has an encoder signal back to these. It compares the signal, make sure everything's okay, correct if it can. If it can't correct, it sets the alarm. It's normally closed, I believe. Yeah, normally closed. And so I've got all that going in series with the big red button. So all that e-stop is connected into these alarms, and it comes over and hooks up between ground, which is DCM, and N1. I mean, you can put it anywhere you want. You just got to tell it in Mach 3 what pin it is, and that would be pin 1. So this is a 24 volt power supply, positive, negative. 24 positive, DCM is the negative. So that powers the board. The 5 volt side gets its power from the USB. All this up here is the 5 volt signal, pulses. And what you got to remember here with these is that you got to kind of choose if you're going to put the return line as positive or ground. I chose positive. So basically all of these are returning to ground. Or actually those are sending the signal out and returning to positive. When you do it that way, you have to, you can see I'm on the second and fourth. So I'm on pulse minus, direction minus. That's what's coming from right here. I'll do the X first. X is black and white. Y is red and white. So X is black and white, and that's the one over to the left. You can see that's X. So you can see black and white. So it's on the second. Again, it's on the second and fourth. The first and third are jumped together. They're tied together. That's the positive. So the positive is going on my third leg, which comes down to they're all tied together up there. It's the ground on these wires, but it's coming down to the positive 5. Now I could have done it the other way. I could have connected that to the ground, and if I had done that to the ground, I would have had to hook the black and white to the positive over here. So you have to have the opposite, right? It has to have positive and negative to flow. Anyway, so that's my 5 volt line. This is my 5 volt line. It's tied to 1 and 3. And my negative pulse and direction is 2 and 4. You see pulse is black, direction is white, and then XP, XD, pulse, direction, black, white. So that's all there is to hooking that up. You hook them up either or, but that's how I did mine. And then you have to go to Mach 3 and set that up. So in here, you're going to go to, if you haven't done it already, you're going to set your native units. Once you set that, leave it alone. And then you go to ports and pins. And when you're using the parallel card, the breakout board, this is the parallel port address. It seems like it just does it automatic for the USB. You don't have to do anything. I've seen a lot of them say that you shouldn't go above 25,000 on the kernel speed, but then I've seen a lot saying that this is a 100 kilohertz card, so maybe it would be better to put it on 100. I'm going to put it on 100, and if I have trouble, then I'm going to just go all the way down to 25K. So right now I'm at 100 because supposedly that red card is a 100 kilohertz card. Then you go to motor inputs. Again, the parallel card needed pin numbers. The serial doesn't seem to care on any of this. You still have to turn them on. This turns on the XYZA. My Y and A were moving backwards, so I clicked these two to make it move the direction that I needed it to move. The input signals right now, all I have is the e-stop. And I don't know if this is correct, but it seems to be working. Port 3, I've noticed online that everybody's using port 3, like it's designed that way or something. I don't know. But so far, that's working. So that's pretty much all I've got hooked up right now. So, okay. And you're going to want to go to slave axis. And on your for mine, I'm slaving my A axis to my Y axis. So you can see it's the X has got one motor, Y back and forth, forward and reverse has two motors. So I can't remember which one of these is my Y and which one's the A, but I had to tie these two together so that they work in synchronization. Then you've got the Z up there. So you have to slave them together. And if you change anything, you're going to have to restart the program to make it take effect. I think that's all I did. Oh, no, you have to, one more thing. You have to do motor tuning. You have to figure out your steps per unit. My unit is 1 inch because I'm working in inches. If you were working a metric, your unit would be, I think it's millimeter. So, because of the micro steps on the stepper and my pitch of my lead screw is 5 millimeter. There's a certain amount of pulses per revolution of the motor itself. You calculate all that out, and I'm using 8,128.01625 steps per unit per inch. So that's going to be the same for all my axes because they are all the same 5 pitch or 5 millimeter pitch on the ball screw, and I'm using the same micro steps. So these are all going to be the same. Right now I've got it set for 80 inches a minute. I may change that, but that's probably all I need. You pretty much want this as low as you can have it and be happy, be satisfied. And if you can't get it high enough, then you've got to look at stuff like a higher voltage power supplies to your drivers, or stuff like that. Maybe kernel speed can help if you got that down real low. But anyway, I'm doing 80. 80's not fast. And I've got the acceleration at 5. If I did a quicker acceleration, it's going to get from 0 to full quicker. And I'm already kind of pushing it. It shouldn't really be more than like half a second. This point should be coming to the top over here. So I've got it kind of aggressive right now. So like if your acceleration was more like 2, let's say, that's less acceleration than 5. So it's slow, it goes up slower. You can see now it's more than 0.6 seconds. So that's real slow. You want it to be right about here. So maybe 2.5 would probably be a good number. Yeah, see, that's just a little more than half a second. So maybe like 2.6 or something. But I'm doing 5 because I do 3D work and I like to have the response time if I can get away with it. But that's another thing. If you're doing a quicker acceleration and you're doing higher velocity, you'll lose steps easier. So that's why you want this to be down as low as possible. Well, anyway, so you do your X. Like I said, you set your steps, your speed, that's inches per minute or millimeters per minute. Depending on, I'm in inches, so that's inches per minute. Acceleration, and then you would save the setting. Go to the next one, do the same thing, which I have the same settings. Z, I have the same settings. A is tied to Y. I don't think you have to fill out A, but I do it anyway. So that's the motor tuning. I think that's it for the connections of the motors or the stepper motors themselves. I think that's all there is to that. I have a shielded USB going from here into the computer and into the other room. It's a really long cable, so I got to worry about that. But that'll keep my computer in the next room where there's a lot less dust. Next, I'm going to have to hook up the VFD. I believe that hooks up in here somewhere. I believe these two. I think there's a 10 volt. There might be a 10 volt. I read somewhere that there's maybe a 10 volt out on this that goes over and gives it a reference voltage. I'll have to look into that closer. But yeah, and then this is just forward and reverse or whatever. It turns it on, and oh yeah, one of them's 0 to 10 volts speed control. But that's what I'll be getting into next. Right now, that's not too difficult really. Like I said, it's just X, Y, Z, A, and whether or not you're doing ground or positive 5 volts. These I haven't really gotten into except for powering the board and E-stop. So this is where you'd set your limit switches and stuff, which I may probably use, but not right off the bat. I think once I get the VFD hooked up and working correctly, I'll probably use it as is, at least for a little while, and that means probably forever. Probably won't get to the limit switches. I think that's it. Oh yeah, my 24 volts. I didn't have a 24 volt, so I'm using right now. I haven't really mounted it, but just using one of these I got from a secondhand store in town. So that's 24 volts. I don't think you need a lot of amperage. I think that one there only has a couple amps available. You probably need a half amp or an amp. So that wouldn't take much. If I found a smaller one, I might grab it and use it instead. Okay. That is the stepper motor wires. Not too hard.